Hi class, Mrs. Calvi here. I'm going to be reviewing different things having to do with inequalities for today. So on my board it says there are at least 25 students in the auditorium. So I'm giving you the verbal phrase and I need to write the inequality based off of what this verbal phrase is saying. So there are at least 25 students in the auditorium. So I need an unknown. The unknown is going to be the student. So S for my unknown. And what is this really saying? There are at least 25 students in the auditorium. That means that there are 25 or more. So the amount of students is greater than or equal to 25. All right. So because it says there are at least 25 students in the auditorium, they're telling us that there are 25 or more students in the auditorium. So the amount of students is greater than or equal to the number 25. All right, let's try another one. Okay, so this one says no more than 150 people can occupy the room. So that means that the room has to have at least, or has to have 150 people or less. So the amount of people in the room has to be less than or equal to 150. Because it's saying no more than, I can have at least 150 in there, okay? I can have 150 people in there. I shouldn't say at least. I can have maximum number of 150, but I can have 150. So that means I have to use this equal bar here to go along with my inequality because I'm allowed to have 150 people in that room, but it has to be 150 or less. So what this is saying is that the people in the room has to be less than or equal to 150. All right. Okay, the next thing we're going to be talking about is graphing inequalities. So here I have x is less than 3. Whenever I am graphing, I want my variable to be on the left side. If my variable is on the left side, then I'm just going to follow the direction my inequality symbol is pointing to. And I'll explain that as I go over an example. So for example, it says x is less than 3. So because I do not have an equal bar under this inequality symbol, it's just less than, it's not less than or equal to. So that's the one thing we need to know. So this is less than or equal to. This is greater than or equal to. That means it's a number and less than or a number and greater than, okay? So looking at this, I'm going to go, I don't have an equal bar. I'm going to go to a positive 3 on my number line, and I'm going to graph it above my number line so I can actually read it. And I am going to put in an open circle right above it. All right. The circle is going to be open because I do not have the equal bar with my inequality symbol. So when it does not have the equal bar, you have an open circle. Now, being that my variable is on the left side, I'm going to follow the direction this inequality symbol is pointing. It's pointing left. So I'm going to draw an arrow all the way to the end, and this is how I would graph x is less than 3. Now, typically, you would see it actually on the number line. You would do this. But it's very hard for me to actually see your work, so I always have you graph it above the number line for me, so it's easier for me to read. Okay, now let's just say that this was x is less than or equal to 3. Say I had that equal bar underneath. Now, the only thing that changes here is that my circle would be filled in. It would be completely filled in because it has the equal bar with it. That means that I'm including this 3 with it. So these values represent, this line represents all of my x values. So all of my x values are less than or equal to 3. So because I have a filled in circle, that means it's equal to 3 or less than. And if you notice, all of these numbers are less than 3. So you have to remember the line you're drawing is representing the x values here. All right, let's look at another one. All right, so here I have y is greater than -2. So first thing I'm looking for, my variables on the left. Good. So step 1, variable on the left. All right. Step 2, look to see if it will be an open circle or closed circle. And then step 3 is to graph. Okay, so step 1, variable on the left side. Yes, my variable's on the left side. Step 2, look to see if it's going to be an open circle or a closed circle. I do not have an equal bar with it, so it's going to be an open circle. And I'm going to go to -2 to graph. So I'm going to go to -2. I'm going to put an open circle. I'm going to follow the direction my inequality symbol is pointing to. I'm doing that because my variable is on the left. If your variable is on the left, you always follow the direction the inequality symbol is pointing to. So this would go in this direction. So this is telling me that this line, these are all of the y values. So all of these y values should be greater than -2. Well, these are all greater than -2. It does not include the -2 because this is an open circle. Okay? All right, so let's take a look at this one. -1 is greater than or equal to y. Well, first step is to look at my variables on the left. It is not on the left, it is on the right. So what I do is I rewrite it with it being on the left side. But you have to make sure it's going to read the same thing. So y is less than or equal to -1. So if you notice, the open alligator mouth, right? You learned this in elementary school. The alligator mouth, right? It's opened up to the -1. When I change it around, it should still be opened up to the -1. So I know I rewrote it correctly. All right. So now my variable's on the left. I'm going to have a closed circle because I have the equal bar with my symbol. So I'm going to go to -1 on my number line. I'm going to put a closed circle, and then I'm going to follow the direction this is pointing. So -1, closed circle, and my inequality symbol is pointing left, so I'm going to draw my line going left. So it's telling me this line represents all of my y values. Are all of these y values less than or equal to -1? Yes, these are less than -1, and because I have a closed circle, I'm including the -1, which means equal to. All right, so it's not so bad. That's pretty simple. All right, so now we're going to be talking about compound inequalities. So basically a compound inequality is combining two inequalities together and graphing them on one line. All right, so basically what I'm going to be doing is graphing both of these inequalities on one line. Now there are two types of compound inequalities. We have compound inequalities that are OR problems, and if you notice I have the word OR here. And then we have what we call AND problems, and I'm going to do that example next. So right now we're going to do an OR compound inequality. So I'm going to graph both of these as if they were separate, right? And watch as I do this. So make sure my variable's on the left, which it is. I'm going to have an open circle at +3. So an open circle at +3. I'm going to have an open circle at -3. And whenever it is an OR problem, I'm going to have my arrows going in opposite directions. Okay? So, which makes sense. So this one, the inequality symbol is pointing in this direction, going to the right. And this one, x is less than -3, it should be pointing going left. So if it's an OR problem, you should have two lines going in opposite directions. If you have them going in the same direction, so if you had something like this, you did something wrong. You should not have them going in the same direction. If it is an or problem, each one should be going in opposite directions. Okay? So because I did not have the equal bars with either of these, they were open circles. All right, let's try another or problem, and then we'll move on to the and problems. Okay, so here we have m is less than or equal to -2, or m is greater than 1. First thing I want to check, my variables are both on the left side, so that works out well. Now here, I'm going to have a closed circle at -2 because I have the equal bar. So I'm going to plot a closed circle at -2. And according to this, it should be going left. So I'm going to draw my arrow left. I'm going to have an open circle at +1 because I don't have the equal bar with that. And my inequality symbol is pointing to the right. And because it's an or problem, I should have my arrows going in opposite directions, which I do. So this looks good. So you can have an open circle and a closed circle. You could have 2 closed circles, or you could have 2 open circles. It all depends on what compound inequalities you are being given. Okay, so remember, if it is an or problem, when you do your final graphing, your arrow should be going in opposite directions. All right, now let's look at compound inequalities when it's considered an and problem. Okay, so this is considered an and problem. It doesn't actually have the word and, it just has the variable in the middle. Okay, so basically this is reading p is less than or equal to 5 and it is greater than 1. Okay, so this is what we're going to do. We are going to plot both numbers, do the plot at the points first. So I have a +1, and this inequality symbol here, this inequality symbol goes with this number. This inequality symbol goes with this number. So I'm going to have an open circle at 1 because I don't have the equal bar here. So an open circle at 1. And then I'm going to have a closed circle at +5. So a closed circle. And whenever it's an and problem, they will connect. Because what it is saying is p is greater than 1. Remember, the line represents the variable. So are these numbers greater than 1? Yes, they are. This is also saying that p is less than or equal to 5. Well, does this line represent numbers less than or equal to 5? Yes, it does. So when it's an and problem, when your variable is in the middle, your lines will always connect. You plot the 2 points, whether open or closed circle, and then just connect them. So pretty simple. Let's try another one. Okay, so it's an and problem because my variable is in the middle. I'm just going to plot these 2 points with open or closed circles depending. So my -3 does not have the equal bar, so that will be an open circle at -3. I have the equal bar for my 0, so that's going to be a closed circle at 0. And because this is an and problem, I'm going to connect them. That means this inequality, this compound inequality, is telling me that everything in between 0 and -3, but including 0, would land within this compound inequality. So my b is going to be greater than -3, and it is, this line, these are all greater than -3, and it is less than or equal to 0. This line, it is less than 0, and it is also equal to 0 because I filled in the circle. Okay, so that is pretty much for graphing inequalities and understanding the difference between compound inequalities and whether you would have an open circle or a closed circle based on whether you have the equal bar included. That is it for now, and I will talk to you guys soon.